Hey guys, good afternoon. I hope people have been enjoying the sunshine. I've got some sunshine up north, which has been really good. But this is definitely, I think, when revision gets really hard because when it's raining, it's pretty, it's all right, isn't it, to kind of just be revising when you're like at home by yourself. But then when you're actually trying to revise and it's sunshine outside, I mean, that is just the worst. I hate that when it's like that. So I have been struggling trying to get up for all of this kind of work. I've been doing a lot of further stats too today, and actually, it's kind of based on some of the things like regression and correlation that I've been looking at. It's not my favorite thing, but I've been doing it anyway. So that's what I've been getting started on today. It seems like people can hear me. I will have my iPad there so I can check on the chat later on. But actually, I've now set it up where I can see the chat on my screen. So I should be a bit better at responding to some of these things in the chat as well. Now, if you've been to one of these live streams before, you know exactly how these work. So, the way these live streams work is I have a calculator here with a random number generator on, and I've also got the PowerPoint, the PDF that I've used before, which has got all of the questions from 2018 to 2022 from AS and A2. They've been organized into different topics, but as I've said with stats, I don't know if you can see it on the screen there, many stats exam questions cover lots and lots of topics at once there. So we're going to pick a random slide. If it's a mark scheme or a different kind of slide, I will go to the next one along. And if we get too much repetition, I will kind of sort of manipulate it a little bit just so we're kind of in the right sort of place. Okay. So we'll get started. Oh, actually, I wanted to ask people, does anybody know what this t-shirt is from? I'm a big fan of this game. Anybody know Cuphead? If anybody knows Cuphead, I immediately will do what I can to help you do even better because I'm a big fan of Cuphead as a video game. I don't know if anyone's played that before. Okay, so someone, just before we get started, someone said, would I say doing all the questions is representative of what comes up? I would say probably about, that would get you about like 80% of the way there. There's always going to be like a twist in the exams to be prepared for as well. Okay. So let's pick this first random number that we've got here. The first random number we're going to go with is 77. Oh, good. There's some Cuphead support here. I mean, I finished the game, but definitely did not 100% it. There was so much going on in Cuphead, and the music is amazing. Can't believe it's all hand drawn. Anyway, yes, I do play Hollow Knight. Love Hollow Knight. Um, but yeah, Cuphead is my favorite. I'll think about some of my other games I really enjoyed. Obviously, Legend of Zelda. Obviously, Legend of Zelda, Breath of the Wild, Tears of the Kingdom, both of them absolutely brilliant. So let's go to slide 77 before I just start talking about video games the whole time. So it looks like it's going to be this first question on the binomial distribution that we've got here. Now, I know this is a little bit small to read. I'm hoping that you guys can see this on your screens, but we're going to go from this one, which is from the AS paper that we've got. So let me just pull my mic across just a little bit further. Yeah, the live stays on the channel as soon as it's finished as well. So they've told us in this question that x has a binomial distribution with 40 and 0.27. And the first thing that it wants us to do is find the probability that x is greater than or equal to 16. Now, I have this little trick. Obviously, my graphics calculator can do this really easily, but greater than or equal to 16 is like 16, 17, 18, 19. So the ones that we want to remove are all of those ones below 16. So removing them means that you would do 1 minus the probability that x is less than or equal to 15. Now, the graphics calculator can obviously just go straight in and do this as well, okay? So on my graphics calculator, I don't use the distribution app. I need to get better at doing it, but I'm just going to go straight in with my binomial cumulative distribution, CD for this question. And I'll do it the way that you'd do it if you didn't have the graphics calculator. So I would say that the lower is 0, the upper is 15. We've got 40 things in the trial and 0.27. Have I put this in right? No, I didn't type it in correctly, did I? I typed in 48 when I meant to type it in 15. So that is 1 minus 0.94907. And obviously, we like to have two calculators in this household. So that's 1 minus 0.94907. I've got the chat here. So if anything goes wrong, I can actually see a bit better if I've got anything that's going wrong in the chat here. So I've got that to 4 decimal places for that first part. It's looking a bit bright. So let's turn down the exposure just a little bit. Okay. So next part says past records suggest that 30% of customers who buy baked beans from a large supermarket buy them in single tins. A new manager suspects that there has been a change in the proportion of customers who buy baked beans in single tins. A random sample of 20 customers who had bought beans was taken. Write down the hypotheses that should be used to test the manager's suspicion. So it looks like the null hypothesis is what we just think is going to be happening, and that's from the past records. We think from past records, the probability is going to be 0.30. That's the 30% of customers there. And it says that a new manager suspects that there has been a change in the proportion of customers who buy baked beans in a single tin. So the new manager just thinks that the probability has changed, that it is no longer 0.30 at this particular case. And we're going to say that there are 20 customers that we're going to have. So we're going to have some new distribution where there is a binomial, and we will assume that H0 is true. Okay, we will assume H0 is true. So there are 20 customers, a random sample of 20 customers, and we're going to assume that H0 is true, so that's 0.30 for the probability. Oh, I've actually gone too far, haven't I? It said write down the hypotheses, so that's part B. Part C is now the next part that we've got here, okay? Yeah, I can probably restrict this to just the A2 questions if this is going to be a good idea. So we can go on with that as well. That's from Azim, who suggested that. So let's have a look at this part. It says using a 10% significance level, find the critical region for a two-tailed test to answer the manager's suspicion. You should state the probability of rejection in each tail, which should be less than 0.05. So it is two tails, and we want it to be less than 0.05. Now, I've actually got the formula book for this, and this is the way that I prefer to do this. So I'm going to go to the formula book for the binomial section, and it's with 20. So this is where I hope I don't bash all of my equipment that I've got set up. So I have it with 20, and you can't see this at the top of the page, but at the top of the page, there's 0.3. So I'm going to go down the 0.3, and I'm going to go to the one that is below 0.5. So that first one is 2, so less than or equal to 2. And then the other one I do is I go to the first one that is above 95%, which is this one, and that's 9, and I just bump it up by 1 for that end. So it's going to be less than or equal to 2, or greater than or equal to 10. So that is just going to be less than or equal to 2, or greater than or equal to 10. And if we want to show that, we can say the probability that x is less than or equal to 2, because it wants us to actually state these probabilities. I can actually just grab it from the calculator. I know I had it in the book, but this is me showing you it as a different way. The number of trials is 20 and the probability is 0.3. Less than or equal to 2 is 0.0355. 0.0355, and the probability that x is greater than or equal to 10, again, you could do it by like a trial and error. That's going to be between 10 and 20. So the lower is 10, the upper is 20, and we've got that is also less at 0.0480. Both of those are to 4 decimal places. And then it says to find the actual significance level. So the actual significance level is just adding these two values together. So that's going to be my 0.355, my 0.0480. And we get, I didn't type it in correctly, needed the extra 0 in front of the 3. And we get that the actual significance level, actual significance, is 0.0835, or we could say it's like 8.35% for this part that we've got. One afternoon, the manager observes that 12 of the 20 customers who bought baked beans bought their beans in single tins. Comment on the manager's suspicion in the light of this observation. So for part E of the question, we can say that 12 is in the critical region. This is the critical region. If it's greater than 10, it's critical. So the 12 is in the critical region, which means, this means that the manager's suspicion is supported. The manager's suspicion is supported. So let's have a look for part F. Part F says there's so many parts in stats questions, which I find really annoying. Yeah, I rounded it up from when I go down on the book. The top one, which was here, was just the first one that was below 0.05. The one that it corresponded to, this it was like 0.952 something. I bumped it up by 1. That's just my shortcut that I've learned to be able to do that. I think I cover that in my playlist as well. So part F says, later it was discovered that the local scout group visited the supermarket that afternoon to buy food for their camping trip. Comment on the validity of the model used to obtain the answer in part E, giving a reason for your answer. So when that afternoon that happened, that there was 12 that was in the critical region, we could say something like, it is possible that the customers were not independent. The customers were not independent, and it has to be independent for a binomial, meaning that a binomial model may not be suitable. Okay, meaning that a binomial model may not be suitable. If someone's asked about the actual significance level, it can be left as this form or it can be left as a percentage, but it's worth noting the actual significance level in this question is lower than 10% because that was the significance level that we had set it at. So we better check that we got the right answers for this. So we did get 0.059 for the first part of the question. We got the two hypotheses here. The critical region was that it was less than or equal to 2 or greater than or equal to 10. Doesn't matter that they did it with y and we did it with x. That's perfectly fine. We have our 8.35%, and then we've got 12 as in the critical region, so it supports the manager's thing. And then what have we got? That the 20 customers should be a random sample or independent, and they're probably not. So that's exactly what we said in this part here. Okay, there was a request to kind of keep this in sort of A2 questions. So I'll see if I can keep it in A2 questions by picking another random number. My microphone is the Sennheiser Profile microphone. It's pretty good. The main thing I like is this arm that we've got here as well. So I'm going to keep an eye on the questions as we go from this one. Someone said, do I have to check each time to see if you can use the binomial distribution by checking the 4 binomial distribution conditions being met? Not really. No, you don't. It's pretty obvious. It's just if they need to kind of criticize it, you'd probably criticize one of those 4 things. Very good, Azim. If you're doing further stats, the actual significance is known as the size, and we want the size to be as small as possible. Yeah, we want the size to be small and the power to be big if anyone is doing further stats. Okay, let's pick another random number that we've got. So I'm going to do my random integer. Let's see if we can get one that's a bit later. I think it was between 1 and 155. And we've got 53. Now, if this is just an AS one, which it probably is going to be, at the request of one of my most loyal subscribers, I think we might go for a slightly harder. I mean, this one I can literally just read through and we can answer it. I'm not even going to write it down. So here we've got there's a company introduce. I'm going to do this super quick because it's so short. A company is introducing a job evaluation scheme. Points X will be awarded to each job based on the qualifications and skills needed and the level of responsibility. The pay Y will be allocated to each job according to the number of points awarded. Before the scheme is introduced, a random sample of 8 employees was taken, and the linear regression equation, i.e. the line of best fit of pay on points, was y equals 4.5x minus 47. So the correlation is going to be positive because it has a positive gradient of 4.5. An interpretation of the gradient of this regression line, an interpretation of that 4.5, is for every time there's one extra point that's awarded for each job, that corresponds to an extra £4.50 for the pay that we have there. And then the last part, part C, explain why this model might not be inappropriate for all jobs in the company, because maybe there will be some jobs in the company that are worth a lot more, worth a lot more kind of points. I want to see how, because of the fact the job might be more challenging. So let's see what kind of things. Oh no, I didn't answer part C very well at all. So for points less than 11, it would give a negative pay, which is doesn't make any sense, but the other parts worked. So the 4.5x minus 47, yeah, I guess I should have said if a job only had like 1 point, it's got like negative pay. So that's what's going on with that one. Okay, so I will go back and just do the random integer, and hopefully this time I'll guarantee that we can get an A-level kind of question. So we have 20, no, 120. That should do us. Okay, we'll go to do 120. To asking about why I bumped up the critical value from 9 to 10, I wonder if anyone in the chat could answer that for me while I go and have a look at this next question. Very good. A conditional probability question. So we have 3 bags here, and each A, B, and C, they each contain 1 red marble and some green marbles. It's only question 1, so it shouldn't be too hard. Bag A has 1 red and 9 green. Bag B has 1 red and 4 green. And bag C has 1 red and 2 green. Sasha selects at random 1 marble from bag A. If he selects a red marble, he stops selecting. If the marble is green, he continues by selecting at random 1 marble from bag B. It's a lot of reading here. If he selects a red marble, he stops selecting. If the marble is green, he continues by selecting at random one marble from bag C. Draw a tree diagram to represent this information. So the tree diagram is going to have a lot of like end branches where he's just going to stop. So I'm going to begin by saying that for the first bag, which is going to be bag A that we have here, there's an option of either getting a red or a green. So there's a red or a green. And for A, that means that red is 1 out of 10 and green is 9 out of 10. Now, if he has a red, he stops. So for the B, it's only if he gets a green here that there's going to be an option of a red or a green. And this is for now for bag B that we have. In bag B, there is 1 red and 4 greens. That's 1 out of 5 and 4 out of 5. And then if he has a red, he stops. And if he has a green, he continues back to bag C. And for C, he's either going to get red or green. There's only 1 that's red out of 3 and 2 that is green here for these branches. And this is for bag C that we have. Okay. So let's look at this next part. It says draw the tree diagram. So that was easy. Find the probability that Sasha selects 3 green marbles. So green, green, green is just going to be multiplying those. So the probability of 3 greens is just going to be 9/10, 4/5, 2/3. Yes, I'm going to do this on my calculator. 9/10, 4/5. This is how I type fractions, by the way. I type all of them as divisions. 9/10, 4/5, 2/3. I just can't be bothered with the fraction button. It looks weird, but I like it. And that's 12 out of 25. Of course, you could give that as a decimal, but I'm very happy to leave that as 12 out of 25. A very easy 2 marks there as well. Part C says find the probability that Sasha selects at least 1 marble of each color. So at least 1 marble of each color means that it's either green, red, green, green, red, and that's it. Those are the only options of getting 1 of each color because you either have red or green, green, green. So the probability of, it's at least 1 marble of each color, excuse me. At least, oh yeah, that's fine. At least 1 of each. That's okay. At least 1 of each is going to be the probability of getting a green, then a red. So it's a probability of a green and then a red, plus the probability of getting a green, and a red. So green, then red, that's 9/10 multiplied by 1/5 because it's an and probability. And then green, green, red is 9/10, 4/5, and then red is 1/3. So again, you're going to see my weird way of typing fractions on the calculator. That is going to be my 9/10 times 1/5 plus 9/10 times 4/5 times 1/3. And we get 21 over 50, which is the same as 0.42 if you want to give it as a decimal that we've got, okay? And then part D of the question says, given that Sasha selects a red marble, find the probability that he selects it from bag B. So this is saying, given that a red is selected, find the probability that the red is from B. So we know with our probability setup that we've got here, the top part is going to be the probability that it is red is selected and it's from B. Well, both of those things being true is just that the red is from B. And then the denominator is the probability that a red is selected. Now, there's a quick way of figuring out the probability that a red is selected, because this is the probability that there are 3 greens. That's the only way that you can not have a red. So if I do 1 minus this probability, that will mean that there is a probability of a red. That will save me the time of doing a 10th plus 9/10 times a 5th plus 9/10 times 4/5 times a 3rd. I'm actually just going to do 1 minus the probability of this branch because that will always guarantee that there's a red. So that is going to be, a red being selected is 1 minus 0.48. And the red being from bag B is 9/10 times a 5th. So that's 9/10 times a 5th. So on my calculator, I'll do this as decimals because 9/10 and a 5th is really easy. So that's 9/10 times by a 5th, and that's going to get divided by 1 minus 0.48, which is 0.52. No more buttons being pressed, please. And that is 9 out of 26. So pretty easy question for this. Let's get something harder as we kind of build up through this session. So we do have the correct tree diagram. Mine is kind of reflected, which is perfectly fine. I got the 12 over 25, I got the 21 over 50, and I got the 9 over 26. I mean, it was question 1, so we should be expecting something that is quite easy like that, right? It would be a shame to have something way harder. So, well, it wouldn't be a shame, it would be quite good. Well, would it be good? If you like maths, it would be good. Okay, let's go between this and 155. Let's get a later question. Let's see if 80 is A2. I don't think it's going to be A2. No, it's another one of those. Let's see if we can. Let's try 127. See what we get with that. I'm doing the random numbers, so I can't sort of prepare for it too much. Okay, should we do this, or do you? It's kind of done a probability question. Tell me in the chat what you'd like me to do. Which topic you'd like me to do? Okay, someone's literally requesting 130. Should we try 130 then? Do you mean this one? I think this looks okay. Tell me in the chat what kind of topic you'd like me to do, and that'll give me a chance to have a sip of some water. It's hot today. Hypothesis kind of stuff. Okay. Yeah, I need to. The spamming is kind of annoying. I should have put that thing on where you can't answer as many questions. Let's pick a normal distribution. Okay, so normal distribution is anything between 133 and 155. I'll adjust that on here, okay? Let's do the normal distribution. Everyone's saying normal distribution and hypothesis testing. We're going to do slide 144. The only reason I do the random numbers is so you know that I'm not preparing for how to do these questions. Let's do this. Okay, so obviously it's normal distribution, but I can tell it's normal distribution pretty quickly because it mentions normal distribution. Please don't send loads of messages. It's just not necessary to send loads of messages. I find it easier if I can just read them more slowly. And we'll do some hypothesis testing as well, okay? So it says a machine puts liquid into bottles of perfume. The amount of liquid put into each bottle, d millimeters, follows a normal distribution with mean 25. So I'm going to immediately write down D has a normal distribution with a mean of 25, but they've not mentioned the variance or the standard deviation, have they? So I'm just going to write that down, and I'm immediately thinking, I don't know what the standard deviation is. It says, given that 15% of the bottles contain less than 24.63. So that's really important. It's just said the probability that D is less than 24.63 is equal to 0.15. That's an interesting statement that they've given there. That statement is going to allow me to find out what this part is equal to. Let me just get this refocused because it's getting a little bit blurry. Okay. This I'm going to use to find sigma. I haven't even read the question. This is classic what I do. I just go like, oh, cool, they've given me something. I can now do something with that we've got there. Okay. So what have we got here? We're going to try and figure out what this is before I even answer the question. They want us to do something else later on in this question, but it's 5 marks, which makes me think I'm going to need to do this in a different kind of way. I'll see if I can. I don't think I can adjust my volume, but it should be. Most people are saying it's loud enough. So the way we do this is we do like our standardizing process, okay? We do our standardizing to find sigma. So we have stated that D being less than 24.63 is equal to 0.15. So thinking about what this looks like as a normal distribution, we are saying that the probability that D is less than 24.63, that area is 0.15. And we're going to standardize this to a normal distribution. That one has a mean of 25. The normal distribution, the standard normal distribution, is going to have a mean of 0. So the way we standardize this is we're going to do, the D is going to standardize to Z. We're going to find out what this value is from the calculator, and we're going to go from there by using the inverse. And remember that Z has a normal distribution with a mean of 0 and a standard deviation of 1. And I'm going to try and find out what is that value there such that the area is 0.15. So on my calculator, I'm going to go to the inverse for my normal distribution. I'm going to do the inverse. The tail is on the left for my calculator, and I want the area to be 0.15. Sigma is 1, mu is 0. So I have minus 1.0364. Minus 1.0364. The hardest thing about this question is they haven't told us that we need to find out sigma. They've asked us something else, but I can't work out that something else in part A until I've done this. So this will standardize to this. This standardizes to that. Now, when you standardize things, you normally take the letter D, you subtract the mean and divide by the standard deviation. That is the process of standardizing. So when I do 24.63 and I subtract the mean, which we know is 25, and I divide by the standard deviation, that will be equal to minus 1.0364. That standardizes to that. When D standardizes to Z, that's how it does it. This is this process that we've got. So I'm going to find out what sigma is, because these are going to basically swap places. So 24.63 minus 25 divided by minus 1.0364 is what sigma is going to be for this. So I'm going to do 24.63 minus 25 divided by minus 1.0364, and this tells me that sigma is 0.357, okay? Now I've established that, I can go back to what I'd written at the beginning, and now I can actually answer part A of this very challenging question. So this means that it has a normal distribution. Whoops, I should have put n at the beginning, with a mean of 25 and a standard deviation of 0.357, and that's all being squared there. And the question now says, find the value of k such that this thing is equal to 0.45. Well, we know something from earlier on. We know something about the 24.63. We know the probability that it's less than 24.63 is 0.15. So if I'm trying to find out between 24.63 and k, I don't know where k is, but I'm just going to put it somewhere on the diagram. If that thing is 0.45 and I know that this thing is 0.15, this tells me the probability that D is less than K is 0.45 plus 0.15, which is 0.6. So I'm going to use the inverse on my calculator again to find out what K is now that I know what sigma is. So trying to show all of this on the screen at the same time, I'm going to be on the inverse normal, and now I know what mu and sigma are. Mu is 25, sigma is 0.357. I want the area to be 0.6 because it's the 0.15 and the 0.45. So this tells me that k is equal to 25.09 because it wants it to 2 decimal places. This is a very challenging 5-mark question, I think. And then we get something that I think is going to be interesting again. I find all of this interesting. We're now going to have a look at part B. It says a random sample of 200 bottles is taken. Using a normal approximation, find the probability that fewer than half of these bottles contain between 24.63 and k milliliters, excuse me. Okay, so a sample of 200 bottles. This sounds like it's going to be like a binomial. So we're talking about there being a binomial where there are 200 bottles, and we're saying what's the probability that they have between 24.63 and k? Well, I know the probability that they have between 24.63 and k is 0.45, and so it's going to be 0.45. So that's it as a binomial. Okay, but they've said something in this question. They have said using a normal approximation. As soon as you see normal approximation, you should be going to yourself, cool, I know what they're talking about here. They are talking about this topic of doing approximations. So it's going to become a normal to find these bits. This first bit is NP, and the second bit is going to be NP times by 1 minus P. So NP is these things multiplied together, 200 times by 0.45. That's 90. Then we do NP 1 minus P, so that's 90 multiplied by 1 minus 0.45, which is 49.5. So now we've got what it is as the binomial, and we have what it is as the normal. So we're going to write what the question says. The question is asking, what is the probability that fewer than half of these? So I'm saying, what is the probability that x is less than half? It's fewer than half, less than 100. Now, for a continuity correction, while I have some water, what do I need to do for the continuity correction to change it first? There's one thing I need to do first before I add on the 0.5, or it's how I do it anyway. Okay. Standard deviation. I can't answer. I actually just don't know about the OCR MEI for that, so I don't want to tell you something and get it wrong. Okay. Okay. Yes. So we need to change this so that it's x is less than or equal to 99, which means we can then change this so that it then becomes y is less than, bump this up by 0.5, less than 99.5. So I can just go straight in using this part here on the calculator. Whew. I've been doing a lot of videos today, so I'm getting... Remember when you type this in on the calculator, you won't type in 49.5 for sigma, you will type in the square root of 49.5. I'm on inverse, so that's not good, is it? Okay, so the lower is going to be a very negative number. The upper we've said is 99.5. I think I've already got this typed in as the square root of 49.5 and that mu is 90. So I'll press that and I get that the probability is 0.9115. Always going to do these to 4 decimal places, okay? We have to increase it by 0.5 here because it's a continuity correction. We're going from something that is discrete to something that is continuous. Okay, you have to go from discrete to continuous. Discrete will go up to 99, but because now we're making it a normal distribution, which is continuous, we're saying, okay, well, actually, anything that goes up to 99.5 would still round down to 99 as well. Okay, good to people that are answering the questions for me. I find that really helpful. This question is amazing. It's basically testing everything to do with the normal distribution. It's kind of crazy. The machine is adjusted so that the standard deviation of the liquid put into the bottles is now 0.16. Okay, so now we have this. We know that D has a normal distribution with 25 and 0.16 for the standard deviation. Following the adjustments, Hannah believes that the mean amount of liquid put in each bottle is less than 25. I can see where this is going. It's going to be a hypothesis test. So I'm going to start off by saying the null hypothesis is the mean is 25. Hannah thinks that the mean is less than 25. Why does Hannah believe this? Well, she believes this because she took a random sample of 20 bottles and she found that the mean amount, D bar, is only 24.94. So this is why she thinks this, right? She took 20 bottles and she found that the average was 24.94. And she was like, well, it's not supposed to be 24.94. It's supposed to be 25. So that's why she thinks it's less than 25. And we're going to decide, is this low enough given that she took a sample of 20? Now I use D bar because D bar is the sample mean. Mu is the mean of all of the bottles, the entire population of them that we've got. So let me move this piece of paper up because it's kind of like a fresh question now that we've got. And you know what you do for this? We have to, first of all, we're going to assume that H0 is true. You never need to write this sentence. It's just the way I like to do it. So we're going to say that the sample means will have a normal distribution with a mean of 25 and a variance of 0.16 squared over the sample size, which is 20. Now, I always jot this down. When I'm going to type this on the calculator, that means that sigma will be the square root of this. The square root of 0.16 squared is 0.16, and it will be divided by the square root of 20. That is sigma squared, so sigma will be the square root of this. And we're going to test her belief. So we're going to say, what is the probability that D bar was less than the thing that she observed? Because we're going to match her hypothesis. She's saying it's less than 25. So we're saying, okay, well, what's the probability it's this or even more extreme? So I'm going to put all of this stuff in the calculator. If the probability is less than 5%, we support Hannah. If it's not, it doesn't matter. We just accept the null. So I am going to say that it's the upper is 24.94. Sigma is 0.16 divided by the square root of 20 and mu is 25. I think that's all good. We have 0.0467. That is less than 5%, which means it's very rare that that has happened. So we will say that this is enough evidence. You don't need to say quite as much of this. You basically just need to say reject H0. To reject H0, this means Hannah's belief. And if you can start telling me in the chat what topic you'd like to do next, that would be great. This means Hannah's belief is supported that the mean is now less than 25. So yeah, I'll be looking out in the chat to see which topic we want to do next. And I'm just going to double check we got all of these right. So we did have the 25.09. Yep, we did have the, let me get, if I've got this right. 0.912, which was my 0.9115. And we got the hypothesis test to say it was sufficient evidence. We got the 0.0467. They had it 0.0468 because they rounded it, but I put the dot, 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 so that is fine. And so we got all of that right. A really challenging question. That was the last question in the 2019 paper. So I know that people will have been finding that challenging. Okay. Okay, we've done some normal kind of stuff. Yeah, people are saying about some AS I think we did an AS hypothesis test. So I did that in the beginning part about the binomial. So should I just pick I'm just going to pick another random question. And if we like it, we like it. If we don't, we'll do another question because we've still got another half hour on this. Okay. So random integer between 1 and 155. Let's try 60. If it looks good, we'll do it. I know what kind of things you guys would like to see. Should we try this Venn? I feel like we've done a Venn question. No, this Venn question I think could be good. No, because it's an easy one. Let's get one later on. I'll tell you what, I'm just going to pick a question. I'm going to pick a question from the conditional probability. Let's do like a recent conditional probability question. Let's try this one. I like these ones where there's a lot of like unknown kinds of things going on. Okay. Yeah, I know people are asking about the D1, everything you need to memorize. I need to do it soon. It's going to be close to the exams. I'm currently still trying to teach myself the rest of further maths and making videos on it. So it will come. It just may be closer to the exam as well. Okay, I'm sorry about that. But I will do it. It's just I don't like decision. It's like my least favorite exam. I really don't like decision at all. Okay, is this going to be the world's worst drawn Venn diagram? Oh, God, probably. So we have the 0.08, 0.05, 0.09, Q, P, R, 0.36. Wait, is that another unknown? We've got a T out there. And then we have capital G, capital E, capital S. So a large college produces 3 magazines. One magazine is about green issues, one magazine is about equality, and one magazine is about sports. One student of the college is selected at random, and the events G, E, and S are defined as follows. Basically, that they read the green issues, they read the equality magazine, they read the sports magazine. The Venn diagram where P, Q, R, and T are probabilities gives the probability for each subset. Find the proportion of students in the college who read exactly one of these magazines. Okay, exactly one magazine is this number, and this number. So exactly one, and then I'll take requests for the final question, is 0.08, 0.09, 0.36. And that is me just going to want to use a calculator. 8, 9, and 36. That's 0.53. It's exactly one because as soon as it goes into these overlaps, it's going to be more than one magazine at a time, isn't it? Okay, part B. It says that no student reads all 3 magazines. So if no student reads all 3 magazines, I'm immediately going to say that P is equal to 0. I'm just going to kind of cross through this P because it's not going to get used anymore. We've also been told that the probability of G is equal to 0.25. So this is pretty easy kind of question I think that we've got because we now know that all of this is 0.25. Notice how I'm not even reading the question. I'm starting doing maths as soon as I see something new that is coming up. Okay. So because the probability of G is 0.25, that means that 0.25 is 0.08 plus 0.05 plus Q. So Q is this 0.25 minus 0.08 minus 0.05. So Q is now 0.12. Okay, well, I'm going to go back to my diagram and say I now know that that is 0.12. Then it wants us to find out that, oh, we've done the value of P and the value of Q. That was super easy. So that was the value of P and that was the value of Q. Look at me ticking my work like I already know that I've got it correct. Okay, now we've got part C of the question, which says, given that PS given E is 5/12. Whoops, that's a closed bracket. Now, if you're in my stats session, you'll know exactly what you need to do when you see this, okay? You need to just immediately transfer this, I think, this is my technique, into the formula, which is that it would be PS and E over PE, and that's equal to 5/12. So we just need to look at what is S and E. Well, S and E is just this overlap because P is gone now, so it's just R. And the probability of E is this, and this, 0.05, 0.09, that's 0.14 plus R, 0.14 plus R, which is equal to 5/12. Loads of ways of solving this. I'm going to multiply up by that. I'm going to multiply it by the 12. So I get 12R is 5 lots of 0.14 plus R. And then I'll just expand the brackets. 5 times 0.14, I think that's 0.7. Yep, so it's 0.7 plus 5R. Subtract the 5R. So 7R is 0.7. And so R is 0.1. I think I've just done a classic not even read the question again. And I want to find the probability of T. Well, we know that all of these things here, now that I know that R is 0.1, all of the probabilities need to add up to 1. So I'll just subtract them from 1. So what I've got 0.08, 0.05, 0.09, 0.1, 0.12, 0.36. And I do 1 minus that, and I get 0.2. So T is equal to 0.2. I probably should have done some method marks for that, but that's not an issue really, because it's just so simple. Yeah, in response to what Toby was saying, I think further stats is, I love further stats. Further stats 1 and the majority of further stats 2 is where it gets so interesting. Stats in normal A level, it kind of puts people off. It's such a shame because the hypothesis testing gets really fascinating. So we're going to determine whether S and E dash and G are independent. So we're going to do our formula for this. We're going to figure out what is the probability of S and E dash. We're going to figure out the probability of G. And we're also going to figure out the probability of S and E dash and G. And then we'll connect them and see if they are independent using this, okay? So S and not E. This is S. And it also has to be not E. So it's going to be the 0.12 and the 0.36. That is 0.48. So that is 0.48. Now the probability of G, they actually told us this earlier on, it's 0.25. So they will be independent if probability of S and E dash and G is equal to 0.25 times by 0.48, which I know very quickly is going to be 0.12. So let's just see from the Venn diagram, S and not E and G. So it has to be, I can finally draw on this because I'm not going to use it again. It needs to be inside S, but it cannot be, oh no, I've crossed off the wrong thing. Whoops, it cannot be inside E, and it needs to be inside G, and I've just crossed off the wrong thing. It's the thing that's underneath there, which is 0.12. So from the Venn diagram, it is equal to 1.2, and I can say this is from the Venn. So because that's true, I can say hence the events are independent. Okay, classic kind of Venn diagram stuff. Yeah, I think further mechanics is my favorite. I love further mechanics. I love further stats. I don't like decision. It's just so easy to do stuff wrong with that. It's definitely going to be my worst module, I think. I've got a video on the large data set, which is really just, I think it's just worth remembering roughly what kinds of numbers you might expect to see for that kind of stuff. The units and things like that seem to be mostly what they ask about, but it's a very small number of marks compared to what people usually do. Not compared to the whole paper, not to what they usually do. Okay, let's have a look and see. So we've done normal distribution. We've done some conditional probability. We better do a regression question just to kind of make sure that we've kind of completed all the kinds of things that we've got. And should we do a large data set kind of one? Yeah, let's do this. Why am I doing this to myself? Is this a mistake? Okay, I'm going to try. Okay. A random sample of 15 days is taken from the large data set for Perth in June and July. Why am I doing this? I don't know why I'm doing this, but it's going to be okay. Oh, yeah, I'll see if I can, after I do this, Azim, I'll see if I can do a question on the normal distribution with conditional. I don't know if there are many in this document, but I'll see if there is one. So, first of all, it's saying that there's 15 days from large data set for Perth in June and July 1987. The scatter diagram displays the values of two of the variables for these 15 days. Describe the correlation. All we need to say here is that the correlation is, you don't need to say the word weak, but I'm going to say that it is weak. I've put it in brackets because it's not essential. Weak, negative, correlation. Phew, at least we can get that mark. It then says, using your knowledge of the large data set, suggest which variable is on the y-axis and state the units. Oh, sorry, that the x-axis is the daily mean temperature. Using your knowledge of the large data set, suggest which variable is on the y-axis and state the units that are used for the large data set for this variable. Well, it looks like that there is a couple of days where it's at 0 on y, but then there are some other days where there's some other sorts of, it's like higher up, and there's also a negative correlation. So it doesn't look like they're integer values, even though there's no scale. So I think my suggestion for this, knowing what's being measured in the large data set for international stations, is going to be rainfall. I think it's going to be rainfall. And that feels like the only one that there is in the international one that kind of makes sense. And it's measured in millimeters. Kind of makes sense. There's a few that are at 0 because there probably were some days where there was no rainfall at all. Okay, see if I can get the camera to focus a little bit better. Why do they put the large data set? It's such a shame. Stav believes that there is correlation between total, completely different thing now, daily total sunshine and daily maximum relative humidity at Heathrow. We're no longer in Perth. He calculates the product moment correlation coefficient between these two variables from a random sample of 30 days and obtains that R is minus 0.377. Carry out a suitable test to investigate Stav's belief at a 5% level of significance. State clearly your hypotheses and your critical value. Well, if you do further stats 2, this is also in further stats 2. I've literally just been making videos on this today, so that's all going to get released later. So the null hypothesis, you have to use the letter rho because it's for the whole population, that rho is equal to 0. And Stav thinks that, what does he think? Does he think there's a positive or negative? He believes that there is a correlation. So the alternative is that rho is not equal to 0, which immediately means it is going to be a two-tailed test. So instead of it being 5%, it is going to be 2.5% for the significance level. And I need to get the formula book, which I dropped on the floor. So we are going to go to the product moment correlation page, which is here. We've got 30 things in the sample, which is, if I can do this without knocking everything all over, which is down here, and we want 0.025. So that's 0.3610. So the critical value is 0.3610, and I'm going to write that down. Critical value is 0.3610. Oh, but I'm doing for negatives, so I'm actually just going to take it as the negative value. And this is where sometimes people get kind of confused. They're not sure like how to judge it. If something is more extreme, if it's closer towards +1 or -1, then we would reject the null hypothesis. So in this case, if you were to think of it as a number line and -1 is over here and here is 0, the critical value is minus 0.3610, and our minus 0.37 is over here. It's in the critical region, which means that the correlation is strong enough. So I'm going to say as minus 0.377 is even more negative than minus 0.3610. If you wanted to, you could say the magnitude of minus 0.37 is greater than the magnitude of this, just looking at magnitudes. If that's confused you, just ignore it. We reject H naught, and we will say this supports Stav's belief. There is correlation. There is correlation. I would write down the whole sentence, but to save you time, I'm just going to write blah, 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 dot, dot, dot. But do write the whole thing out as well, okay? Yeah, if your row looks like a P, you wouldn't lose marks. Just do like that, and it's like it obviously looks like you're trying to do row, okay? Then we have part D of it. It says, on a random day at Heathrow, the daily maximum relative humidity was 97%. Comment on the number of hours of sunshine you would expect on that day, giving a reason for your answer. So we have said that this correlation coefficient was significant. We've said that there is correlation, and it appears to be negative correlation. So I'm going to say, as the correlation is negative, and 97% humidity is high, because obviously it only goes up to 100%, we would expect a low number of hours of sunshine. I think sunshine is measured in hours to one decimal place. Okay, let's see if this was enough for this. So let's look at the mark scheme. Negative, you didn't even need to say weak, just negative correlation. It was rainfall or pressure. So rainfall or pressure. Pressure is hectopascals, or you could have said pascals, any of those things. And we got this right, so we rejected it, but they do need to have, I put ... it does need to have sunshine and humidity. They're underlined, so it needs to be mentioned. And as humidity is high, there is evidence of correlation. So expect the sunshine to be lower. Oh, they want it to be lower than the average for Heathrow. So I guess I should say low numbers of hours of sunshine compared to the average. This is where I'm going to be losing marks. The little written questions. I think everybody kind of feels like that for these kinds of things. Okay, I'm going to see if I can find, as requested by Azim, a kind of tricky normal distribution question that has some kind of conditional kind of stuff in it. Does this one have conditional? No. We also don't have that long, so I'm going to have to pick an easier kind of parts. I know this one does, but actually I think, Azim, I went through this in one of the sessions, so you don't want me to go through this question because I've already gone through that one. I'll pick a nice kind of normal distribution question, or what I might do is this one that was done recently because it looks short and I might be able to finish it, because that will just take us nicely up to the end of this bit. A slightly easy one to finish with that we've got. We'll just do a quick bit of a normal approximation. So George throws a ball at a target 15 times. Each time George throws the ball, the probability of hitting the target is 0.48. And this is just a classic binomial to begin with. So we have the binomial, it's an x binomial distribution. If x is the number of times that he hits the target, 15 and 0.48. That's one of the marks. The next mark is literally just getting the correct values from the calculator. This is the probability that x is equal to 3 and then greater than or equal to 5. Now, if you don't have the graphics calculator, I don't have it, I lost it. I think I lent it to a student and they never gave it back to me. So in binomial, you would do PD for this. In graphics, I actually still would probably do it with CD. I would just make the lower and the upper both 3. Number of trials is 15 and the P is 0.48. So you get 0.0197 to 4 decimal places, okay? And then for greater than or equal to 5, if I was doing it not on the graphics calculator, I would do 1 minus the probability that x is less than or equal to 4. But I have the graphics, which means that I'm going to say greater than 5 is going to be between 5 and 15. And we don't need to show any more working, 0.9201 to 4 decimal places. And then for part B, we're going to do a continuity correction, right? Part B says George now throws the ball at the target 250 times. So we now are having it as a binomial with 250 and 0.48. Use a normal approximation to calculate the probability that he will hit the target more than 110 times. So we're going to make it become a normal. We know how to do this because you do NP for the first part. That's going to be, on my calculator, 250 times by 0.48. It's 120. And then you do NP, which we've just worked out, and you multiply it by 1 minus P, which in this case is 0.52. And that is 62.4. Remember, when you type in sigma, you'll have to do the square root of 62.4. So the thing that they're interested in is they want it to be more than 110. X has got to be more than 110. We did this earlier on. The first thing that we're going to do is make sure that we change it to an or equal to. Greater than 110 is greater than or equal to 111. So now when I make it become a normal, it's going to be that y has got to be, well, it's greater than 111, so I'm going to bump it down this time because it's a greater than 110.5. 110.5. So on the graphics, I'll be using all that information there, jumping out of binomial and into normal. I will put that the lower is 110.5, the upper is just a big value. Sigma is the square root of 62.4, and mu is 120. And we get 0.8854 to 4 decimal places. So I kind of haven't really seen many questions like this. Now, we've got 5 minutes left, so if you want to ask me some general questions, whether it's to do with statistics, you can start putting those in the chat whilst I check through these. So I got that one right, and I got that one right, and I got that one right. So we finished with a slightly easier one than what we've started with in this. We did do some hard questions. The normal distribution about the soap, I think it was, in a bottle. That was quite a hard one, I think. So I'm probably, for my next live streams, probably going to do some stuff on like exam papers. I'm probably going to start doing some of the exam papers I don't have on my channel. And yeah, I've done most of the questions before. I figured it would be useful for people to see like what I'm doing in them, and you can kind of come along for whichever part of the live stream that you want to. Yeah, what did Jamil just say? Do we need to know the standard normal Z stuff? You don't need to know the stuff that I've done in some of the videos where I use like the letter phi, like you don't need that. All you need to know how to do is to standardize Z so that Z is X minus the mean divided by the standard deviation. You need to know how to do that kind of stuff as well. Will there be any free further maths content? There is for core pure, but I'm afraid for all the stuff for applied, I've been working so hard on the applied content this year that I've had to put that for members, just because if I didn't have it paid for, I wouldn't be able to kind of do that. I wouldn't be able to create it at all. I might do like a further mechanics one, just because it's one of my favorites. I might do a further stats one, but that won't be for a while because I'm very busy and I'm trying to prioritize quite a few things at the moment. The schedule for the live streams, I haven't published a schedule because I just don't know my availability over these next few days whilst I'm working on different bits and bobs. So at the moment, it's more likely that I will be publishing the live streams a few days before on my Instagram. So if you're not following me on Instagram, same handle, Bicen Maths. And if you're not looking at like the community tab, if you go to the community tab on YouTube, that's usually where you can find out like when my next live streams are going to be. And they're always published a couple of days before, so you can keep an eye. I do want to do a schedule, but the trouble is when I do a schedule, I'm then worried I'm going to have to cancel one of them. So that's why I'm normally doing it a couple of days before. Yeah, I'm going to do a couple of core pure papers. I think that would be good as well because I want to try and finish these up. I'm not going to be doing any of the step kinds of questions, I don't think. If you apply a force to a laminar but not add a particle, will the center of mass change? No, absolutely not. The center of mass is nothing to do with forces, so it would all stay like completely fixed as well. Yeah, Azim is saying it's worth paying for. I appreciate that, which is really, really good. So we might finish up a few minutes early because there's not that many questions in the chat today. Maybe people don't like stats and they just kind of want to ignore what is going on here. Okay, let's have a look. Hamna says, can I give any tips for statistics as you keep making silly mistakes and it's costing your grades a lot? So I think what I would recommend is when I ran my aiming for A-star session on stats, which is available, it's linked in the description. You can get the recording of it. I kind of go through each of the topics and say, this is how you should approach this. If you see this question, this is the exact kind of ways that you should answer it. So when you're looking at a question, try and spot the patterns of things that are happening, Hamna. Because if you can see like when it's a normal distribution question, like that one we did earlier, and if you can spot that it's like, okay, that's a hypothesis test. I know how to do that. Oh, that's missing standard deviation or missing mu. I know how to do that. It will help you to be a lot better in those questions. And ultimately, practice is going to be the thing as well. What's the hardest topic from stats that I would recommend revising? The hardest topic is probably the normal distribution stuff, normal distribution where it's like a worded kind of question. So making sure that you can do all of these questions from the normal distribution section of this PDF would be really useful. That's all in the link of this video, so you can download that and practice some of those questions. And then for mechanics, it's moments. It's like the rigid bodies like ladders and things like that are the hardest kinds of things that we've got. Oh, thank you for saying that you appreciate all the work I do. I really like that. Thank you so much, Aaron, as well. I really appreciate that. Okay, tips for timing. Yeah, for timing, I would say the main thing is about knowing when to give up on a question. I know that sounds really silly, but giving up on a question can actually be a really positive way of getting more marks. And so it's about knowing that you need to kind of bail on it at some point. At some point, you're going to bail, and that's a good thing. So don't just keep thinking, I need to get this 2 marker, I need to get this 2 marker. No, it's a good time to give up and kind of push forward with stuff. Any tips for Further Mechanics 1 and D1? D1, I haven't got as many tips on because I'm a newbie to D1. I need to do a lot more practice on that before offering tips. For Further Mechanics 1, I can see that you're a member of the channel. The Everything to Memorize playlist for Further Mechanics, not playlist, the Everything to Memorize video for mechanics, Further Mechanics is it's me being like a bit arrogant, but it's really good. It's really good. So if you can just see that Further Mechanics is just that one document, that will put you in a much stronger kind of position. Thank you, Hamna. I appreciate that as well. You have to use Z values if you ever have. This is in answer to who's asked about Z values? Kermit, if that is your real name. If you ever have something that's got a normal distribution where maybe you don't know the mean, but you do know the standard deviation, or if you have a normal distribution where maybe you know the mean, but you don't know the standard deviation, this is where you have to standardize them to normal distributions with 0 and 1. That's when you have to do the standardizing process with the Z values that you have there. You're very welcome, Toby. Thank you. What else have we got? Predictions for grade boundaries this year. Yeah, my predictions for grade boundaries is I would expect to see very similar to 2023 in terms of the paper's difficulty and also in terms of the grade boundary. I'm not expecting like a major upset of things getting harder or easier, but I will comment on that more once I've sat the first paper and have a bit more of an idea with this. Okay. Yeah, I know what you mean. I'm a bit worried about Corpio if a tricky question comes up, but the main thing, Azim, to remember is that if that kind of question comes up, everybody is going to be stressing. So just make sure you're getting all the marks elsewhere and that you try and get as much as you can outside of that question, in that question and outside of that question. But if there's a part that you know is like really crazy, just leave it. It's just not the end of the world. You're trying to get a high percentage. You're not trying to get 100%. I do not use the formula book for the Z values. I would just use the inverse button on my calculator. I never end up using the Z values bit that's in the formula book, even for further stats as well. Or maybe I do sometimes for further stats, but definitely not for normal maths. My opinion on last year's paper for maths and further maths. For maths, my opinion was that the paper was much more accessible. What I mean by accessible is it was, I don't want to say the word easy, but it was like you could do lots more of the marks in the questions. And that's why the grade boundaries went up. For further maths, it was hard, which is where the grade boundaries didn't really change here. I might do a Further Mechanics 1 live session, but it won't be for a while because the Further Mechanics live session is a little way off. Okay. When I have a variable with a Z distributor, oh, so people are answering that. Okay, good. One more thing, tips for Further Mechanics springs and strings because I find it very hard. Yeah, if you're doing further mechanics, whenever you do the energy kinds of questions, always start off thinking you've got your EPE, GPE, and KE. You'd have that on both sides. And then just cross off the ones you don't need. Write down any key values underneath them, like what the height is, what the extension is. It just helps you kind of keep organized with everything that's going on. So that's a little tip for the person who asked that question. My last question, I'm not going to answer any more after this because I need to start making my dinner. Someone said, plateaued in terms of marks despite practice. How do I solve this? I would encourage you, Eugenia, to go and have a look at the questions you're getting wrong and to try and make sure that you've understood them either using a video or using mark schemes, and then repeat those questions a few weeks later. Because if you still can't do them after a few weeks and you've reviewed the mark scheme, you haven't learned what that new thing is in that exam question. And they do repeat exam questions quite a lot. So I would try and find the ones you're getting wrong and really practice them as many times as you can. It sounds silly, but it will help you push and go beyond that plateau that you've got there. Okay. Marks wise for each of the further, each of the further maths papers, you need to be aiming for, I can't remember what the A star boundary is. I'm not sure. I'm really sorry. So I think the A star boundary is like 77. So you should be aiming for like 85% in all of them. Guys, I'm going to log off now. I hope that everybody has had a good day at school. I'll start doing some of these when study leave comes during the daytime as well. And I'll probably be doing some before. Yeah, Moes Lewis, if you go to the description, there's a link to the box office. At the bottom half of that is where all of the recordings from my sessions are. They've got an average of like over 4.8 stars out of 5 from like 300 reviews or something. So people really like these sessions. You get about 2 or 3 hours worth of content. So when you look at the price for it, realize that if you divided that by the number of hours, it makes it really cheap for what it is per hour for like a tutor. And I know what I'm talking about. So if you like the way I teach things, I think a lot about this exam and I try and make it like as good as I possibly can do. So people have really enjoyed those sessions. So definitely kind of check those out. Okay. Guys, I'm going to finish this up now. And I hope everybody has a great evening. I don't know. I'll probably be doing a paper walkthrough next. I don't know when I'm doing it though, because I am deep in further stats 2. After further stats 2, I've got to put myself through all of decision 2. And shout out to anyone else who likes